So, complex numbers. Let's take a look at it. Yeah, we've seen these before multiple times. Remember, a plus bi, I came from the square root of -1, so numbers like 3 plus 4i, and we did all the other stuff with the conjugates and adding and multiplying and do all that other stuff. Well, how do we graph one of these numbers? Well, really what we do is we think, instead of being x horizontal, we really think of this as the real number line. Okay, that's what we normally think of as a number line, horizontal. That would be our a. And the vertical, instead of thinking y, that's our imaginary number line. Our imaginary, that's where the b is. So 3 plus 4i looks like 3 real, 4 in the imaginary direction. That's where a is. b, -3 plus 3i, so -3 real, 3 in the imaginary direction. Where do you think c would go? -2 minus I, or 1i. Right there. Okay, pretty straightforward. Horizontal is real, imaginary is your vertical. Okay, now how do we get the absolute value of those numbers? Remember, absolute value meant what? Exactly. So how far is this? How far is a from 0? What is that distance? You're right. We get just the Pythagorean theorem. So b, square, again, we don't care about positive or negatives because we're only looking at distances. Simplified, of course. Square root of 9, square root of 18, or 2 squared plus 1 squared, square root of that. Again, because that's really what we're looking at. What is this distance right here? Okay? And what is that distance? Well, how far is that from 0? How far is c from 0? Looks like we've done that kind of thing before. Okay, which we have. So now, complex number. So the complex number 5 plus 5i in trig form is this. 5 square roots of 5, it should be, 5 square roots of 2. You got me there. 5 happy. Cosine pi over 4 plus I sine pi over 4. Well, let's see, where is 5? Would be, let's see, 5 square roots of 5, where is that? Right there. Right there. So that's where this point is placed. Right there. Okay. So where does this 5 square roots of 2 come from? Well, if we look at that, your absolute value, your r. How about pi over 4? What do you think pi over 4 is? That angle right there. So pi over 4 is the angle, and this is the absolute value. Now, we've seen, if we just look at it in terms of, as we were looking some other things before with polar, and I mentioned it, you saw it up at the title, polar form. Well, from rectangular to polar, this is r, and this is your theta. And that's all that we really is. That's all we're trying to do, is taking that rectangular form to a polar or a trig form for the complex number. So let's do the same thing here. Let's do that right here. So I'm going to put this complex number, that was 3 plus 4i, and put it in trig form. Well, first of all, what's the radius? What's the absolute value? So I'll write it over here. R was 5. Again, I'll write that in a second. I'll write that down in a bit. Okay, that's the absolute value. So this would be 5 times cosine of some angle plus I times the sine of that same angle. Now, what was that angle? So again, go back to the picture here. This was 3. This is 4. What's that angle right there? How do we get it? So theta is inverse tangent of 4 over 3. I already did that before and come up with 53.1, and that's what we have here. Again, doesn't matter degrees or radians. That's it. Now, B. Okay, so anyways, let's go back up to here. What about the trig form? So R is just what we thought it is, but instead of using X and Y, we're going to use A and B. No I involved, because again, I is just direction, not a length. Theta, quote, reference, is the inverse tangent of the B over A, because the B is your vertical and A is your horizontal. Again, to the reference angle, to the x-axis. That's the way it's going to be. Again, we don't worry about positive or negatives when we think of that way. So B, what was our R? Again, what was B? Negative 3 plus 3i. So the radius, absolute value, oh, there we go, was 3 square roots of 2. What was the angle? Now, again, looking at this, we could probably tell by looking and say, okay, what is this angle here? That's the angle we're looking at. That's the theta. That's the direction. Or if you use the reference angle of legs are the same, 45, that's going to be 135, because we've got to make sure we're in the correct quadrant. So cosine 135, yes, you can use 3 pi over 4. So cosine 135 plus I sine 135 degrees. C. Again, we've already did the R before, which is the absolute value, the radius, cosine plus I sine of that angle being the same. What was it? Well, let's see here. So our reference angle is 1/2, inverse tangent of 1/2, which punched it in already, 26.6. Now where is this angle? What quadrant is that in? Then quick, negative real, negative imaginary. So there's your 26.6 right there. Add 180. So 180 plus the reference. Again, make sure you're in the right quadrant when you do these. Your theta's got to have the correct quadrant. By the way, in complex numbers here, the R is going to be greater than 0. Actually, we could be equal to 0, but that's boring because that's the origin. That's a real number of 0. Okay? So when we don't deal with that opposite angles or anything like that with just plain polar coordinates. Here we have this other condition on it, and that's useful for other things that we're going to do later. Okay, now how about if we switch that? How do we write it in standard form? So in other words, we want to go from this trig function to a plus bi. Well, considering this is the radius and an angle, so if we picture radius of 12 at an angle of pi over 6, what's this a? What's that b? It's already there. So really, it would just be basically multiplying 12 cosine of pi over 6 plus 12 times the sine of pi over 6. That's the b times I. So cosine of pi over 6. Yep, if it's an exact value, we need the exact value. If it isn't, then don't bother. So 6 square roots of 3 plus 6i. Do the same thing here. 8 cosine of 315 times I. So reference is 45. Quadrant 4. Cosine's positive. Sine is negative. Now again, this is a few more actual teacher steps. I could see you go from here to here. This kind of thing. So this step here with the distribution may not be a necessary step for you, but I'd like to see this, should see this. That'd be more the required step. And of course, the answer of 4 square root of 2 minus 4 square root of 2 times I. Sometimes you'll see that I, because of the nature of the square root, look like this. But I'm not going to worry about it just because is the I under the square root or not? Well, this avoids it, but this is fine for us. In fact, that's how you're going to see me writing it. Here, same thing. So cosine of 5 pi over 4, reference is pi over 4, quadrant number. Oops, I missed an I. An I for an I. So square root of 6. Oop, wrong color. Bye-bye. Square root of 6 times negative square root of 2 over 2 plus square root of 6 times the negative square root of 2 over 2 I negative square root of 12 over 2 minus the same thing. That's nice about the pi over 4s or the 45ers. Let's see here. Ooh, square root of 12 is 2 square roots of 3 over the 2 over the 2. Bye-bye 2's. So this number, negative square root of 3 minus square root of 3i. Now if these are not special angles, then you reach for your calculator, punch them in, round to an appropriate number, usually the 10th or 100th. Okay, get going on those on the first assignment.